Hey everybody, so here is tutorial 5 part 2 where we cover some new material, and the first thing that we're going to cover is creating a project. So we've been creating a new patcher so far this semester. Now we're going to create a new project, and a project lets us create a folder on our hard drive. So we can call it tutorial 5 part 2 project. And it creates a project. It wants to create it in the projects folder of the Max 8 folder, but I'm going to put it in the class folder. And you want to always keep your files organized to make sure you know where they are. I'll save it in the multimedia folder, tutorial 5 part 2 project, save. And that gives us this new window that we haven't seen before with a big plus on it. And the nice thing about this is now we can take all sorts of stuff and drag it into our project, and it'll all be grouped together. So here I have a bunch of audio files that I want to be in my project, so I can just drag them and drop them, and they're now part of my project. They haven't been moved into the folder yet. Let's take a look over here and take a look at this tutorial 5 part 2 project folder. If we look inside, there's just the project file. These audio files haven't been moved yet. They've just been referenced in their current location on the hard drive. So similarly, we can take a patch like this tutorial 3 for project MaxPat, drag it, drop it into my project, and it becomes part of the project, but we see it's in italics because it hasn't actually been moved into the project folder. So things are organized in the sense that we can access them together in the project file, but nothing's been rearranged on our hard drive. If we want them to be rearranged on our hard drive, we just click here on this Manage Project icon, and we say Consolidate. And now what happens is everything gets moved together into the project folder. So my audio files have been moved here into Media, and my patcher has been moved here. And in fact, they haven't been moved, they've been copied. So if you go back to the original location, they're still there. All my audio files are still in my AIFF folder here. And if we go up a level into my multimedia folder, we'll see there's another copy of tutorial 3 for project MaxPat. This can get confusing. So what I do when I add a patch to a project and then consolidate the project, I'll go back and delete copies that I don't want. So I only want one copy of this tutorial 3 for project, and I want it in my project, inside my project folder. So once you're managing things in terms of a project, it makes certain things quite a bit easier. For instance, I'm going back to tutorial 3 here, kind of rewinding, because I want to look at this idea of multiple audio files. As we've discussed, stems, that's how you're going to be working on your final project. Go in here to my sound player and drag, as we've been doing, I can drag my drums in here. I can drag my bass in here, drag my synths in here, my other synths in here. As you can see, I've already kind of set this up for this particular song and vocals, and as long as our audio is on, we can listen to it.
Sometimes I feel I've got to run away.
Okay, great tune. But what I can do, you'll notice here, is something new. I can use the @AudioFile attribute to specify the file I always want to be automatically loaded in there. So I've already done this. @AudioFile drums.aiff, @AudioFile bass, @AudioFile synths. And notice that the capitalization does need to be correct. So bass is lowercase here and here. Synths is uppercase here and here. Other synths is going to potentially be a problem because it's got a space in it. So I'm going to reveal this in the Finder and take the space out. You just don't want spaces in file names. I'm going to re-add this to my project and remove this one from the project. So we've got other synths with no space. other synths.aff, and lastly at audiophile vocals.aiff, and I've loaded all of these sound files in. And of course you'll have different sound files for yours, and it should all be there. Let's check. Yep, and now the real test is, let's close our project and reopen it. Say File, Open Recent, Project, Open Recent Project, Tutorial 5 Part 2 Project. Everything comes in, my sound player is all set up, and it should just go without me reloading anything. Let's try it. It does. Now, while we're in here, we can notice a couple of things. One, take a look at the bass here. You notice that the bass is only in one channel. It's being brought in as a stereo file, but the bass was only recorded on one channel, and that's going to really affect the quality of the sound. First of all, it's going to put it only in the left ear, and in doing that, it's also going to make the bass sound very thin. So what we can do is all these routing patch cords right here are routing the left and right channels of the audio to the left and right ears, so we can make changes to that.
Now I'll run from you.
So there's our bass. So what I've done there is I've taken the left channel, the left output channel of bass, and sent it to both the left and the right output channels of my computer. So here, if I colorize those, you can see it a little bit better. Change the color of those patch cords. These two red cords here, right? I'm taking this, and I'm getting the average amplitude of it and sending it to bass. But also, I'm taking the left output of my SF play and routing it to both the left and the right channels of my actual sound output. So now in my headphones, I'm not sure if you can hear this in your video, but in my headphones, the bass went from just being in my left ear to being in both the left and the right ears, and very perceptibly thickened in its sound. So you can adjust levels, and you can also adjust sound routing here in the software. So I'm going to restore these volume levels. And also, if you want to restore these volume levels quickly, there's other inlets here where you can remote control your amplitude. See, in decibels. So if I want these all to go back to any particular gain point, I can just connect a floating point number box to all of them and alter the volumes of all of my sounds or any grouping of sounds. And just to get them to all go back to full volume, I just type in 0 and hit return, and they all return to 0 dB. So that's our sound player left over from tutorial 3. And I just want to start with that because I don't want to move too far away from the fact that we're making sound responsive projects here, but I'm going to get rid of the rest of this stuff from tutorial 3. But if you haven't gone back and reviewed tutorial 3, you may want to do that because that was useful material. And also, this is no longer guitar, this is the synthesizers now, because I changed that here, send SYN, so I have to change the corresponding R SYN out here. Make sure my sound player buttons still work. Seek and pause. Seek and pause. Great. Okay, so what was our imagery in tutorial 3? Well, let's take a look. We have a jit.matrix with 10 cells. It's going to give us just 10 objects in our world, and we're spreading those out along the x dimension over 20 meters from -10 to +10 meters. And we're generating some colors here to color those. And we should be generating some scale here. So we'll just use a little scale. And note, the proper way to name a jit.gen is at title scale. And that, when you open it, will show the name at the top. So this one should actually be jit.gen at title norm, and this is jit.gen at title scale. And all we're doing in here is just assigning every one of our objects to a scale of 1. And here we're generating some pattern to go into those objects. And we can see it just gives us a row of cubes. They're patterned here, they're scaled here, they're colored here, and they're positioned here. And as we've gotten the habit of doing, we can just connect this up to the middle outlet of the jit.world, or to receive, I'm calling it frame in this case, receive frame. So let's take a look at some other things that we can do here. One of the things we can do is we can move into a second dimension. So instead of just a row of 10, we can make a grid of 10 by 10. And once we're working in a grid format, we no longer need to swizz out the dimensions. And then we can take some start to get creative with the placement. These don't have to be laid out in a grid. In fact, a grid isn't necessarily that interesting. Jit.noise, which instead of giving us controlled random like jit.bfg, jit.noise just scatters things entirely through the range. So if I can actually replace my jit.matrix with my jit.noise, or I can just pass my noise into my matrix. When I send the noise, I'm no longer going to take the normalized coordinates. I'm just going to take that noise and use it to position these objects. And they're all jumbled up. Now notice that they're all jumbled up in the top right quadrant, because the noise that's generated here is a positive value. It's from 0 to 1. So it's a 10 by 10 grid of 3 values per grid location with random numbers in each location from 0 to 1. And if we want this to be spread out evenly throughout the space, we need to subtract 0.5 from that. So we're sliding it down and to the left by ½ meter. And now it's going to be randomly arrayed around the center. And notice that it's spread out in the z dimension as well. Right, so this is a random cube of cubes. This pattern's a little bit distracting. Let's get maybe a subtler pattern on these. It's not very subtle. Let's go to some gradient noise. Oh, that's a much more subtle pattern on those cubes. So it's a 10 by 10 array, if you will, 100 values, but there's random values being placed into the x, y, and the z values at each of these positions. So we get our objects spread out in a 3-dimensional randomized space, and that's pretty nice. But and it's useful to be able to create total randomness. But we might also want to mix that with some controlled randomness. So we could, for instance, just copy our p colors, and we'll make it p BFG. Let's call it PBFG, and go in there and create some 10 by 10 BFG noise and add that to our completely random noise by using finally our second inlet here of jit.gen. And we can actually simply add these together by attaching them to the same inlet, or if that makes you nervous, you can just use a plus object to add them together. But once you're inside of jit.gen, you can add things just by sending them to the two inlets of the plus. And let's see what that looks like. Since I don't want to change my total randomness very often, but I do want to change my BFG every frame, I'm just going to swap these. I'm going to put the jit.noise into the right inlet and put the jit.bfg into the left inlet, because the jit.bfg is constantly generating new positions. So when I make adjustments to my jit.bfg, I can see my totally random noise being changed by my organized noise, which creates for a nice combined motion effect. And we can take that and we can turn it into a landscape that we can actually move through if we begin changing our Z dimension as well. So we can take our X and our Y, like so. And then do something totally other with our Z. For instance, we can just add the current time to our Z, which will make all of our objects move in the Z dimension. So we can make a param, we'll call it T, and we'll just add T to our Z value and see what that does. And then T will be time. Take our time, put it into our jit.gen. We'll change the title of this to position because it's no longer normalized, and see what happens when we start up the music. So you'll notice what happened is the time is being added to the Z position, which makes the cubes all move towards us in the Z dimension, and that's pretty neat. And it works really great until all the cubes are behind us, and then it's a very short music video. Oh well, what are we going to do about that? Because it starts off really beautifully. We're flying through this cube space. We're not really flying through this cube space because our camera is not moving. The cubes are moving towards us, right? And of course, everything is still interactive. We can still change our noise here. We can still move things around with our BFG. That's all interesting. But our problem is our cubes all go behind us. So here's where we're going to learn a new thing, which is very handy, very, very useful. You'll see it all the time in animation and motion graphics and any kind of any kind of multimedia application where there's repetitive motion, sort of like sine and cosine. It needs to be part of your toolkit. It's modulo, which is often abbreviated mod, or will sometimes appear as a percent sign. And when you modulo, it's it's a very simple idea. Modulo is division, except instead of giving the answer, it gives you the remainder, right? So 11 mod 10 is 1, because 11 divided by 10 10 is 1 with a remainder of 1. So mod is division, but the output is not the answer to the division, it's the remainder of the division. Now, why is that nice? That's nice because it's another way of turning linear processes into cyclical processes. But instead of producing a circular cycle like sine and cosine do, mod produces what we call a sawtooth. It's a value that continually rises, and then when it reaches a limit, it drops back down to 0. So a repetitive sawtooth, because, if you think about anything divided by 10, 10 divided by 10 is 0, 11 divided by 10 is 1 with a remainder of 1, so 12 mod 10 is 2, 13 mod 10 is 3, all the way up to 19 mod 10 is 9, and then 20 mod 10 jumps back down to 0 because there's no remainder. So this, take a look at what this just does for us. When things get close to us, they jump to the back. So we get an infinite fly through space because as things pass us, they jump to the back. Now, they're not quite passing us yet because our numbers aren't good here. We probably need to expand this out. Let's just multiply it by 10, make the whole depth of the space. Yeah, look at that. So now we got cool blocks flying towards us. Lovely. And of course, we're starting from a basic noisy randomness here that we can change the position of those blocks. And we've also got a smooth BFG randomness here where we can move stuff around a little bit. Now, what's wacky about this BFG thing is we don't want it moving things in the Z dimension anymore. We really only want X and Y. So really in here we would swizz out the X. We haven't done this before, but we can just swizz XY like this. That should actually do the trick. Let's see. Go into our BFG. Yeah. So now we've just removed the Z modification. So our blocks are going to scoot around as they fly towards us, but they're not going to weirdly move back and forth in space. So let's drive this with time. See what it looks like. Oh, craziness! All right, let's divide this by 10. All right, so now we got some nicely flying around blocks, and we're flying through them. Man, I like it. It's pretty great. What else can we do here? Oh, well, we can certainly have some modifications based on the sound. For instance, we can modulate the position here that we're modulating with time, also with the drum beat. So, for instance, let's make an inlet to our patcher here, and just alter the scale of our noise directly from the drum beat. We'll just take the average amplitude of the drums, send it straight to the BFG, and see what we get. It's a little jumpy. Let's take it, and rather than sending it to the scale, we'll remove that time and just send it to the offset. See what that does. Oh yeah, that's nice. And I could also use a threshold here, like we've seen before. I could say greater than when the drum level is greater than 0.1, something's going to happen. For instance, maybe we'll get a new noise, a new totally random arrangement. And if you remember, the tog edge object allows us to say when this happens, or when it finishes here, but in phase with the input. When this happens, when it becomes greater than 1, then do this. We're going to get a new random arrangement every time the drum is at a level of greater than 0.1. That's nice. That's kind of dramatic. Still finding this is very upper right-hand corner biased. I'm not sure why that is. It looks like it's not a function of the noise, so it must be a function of the BFG. So maybe we've got to just pull back on that a little bit as well to center things. Oh yeah, that's a much nicer arrangement. Yeah, definitely. Now, one thing we can do, here's a little trick. You see how these objects in the background are kind of popping into existence? They're passing us really nicely, and when they disappear behind the camera, we don't so much mind, but they pop into existence in the distance. So, we can solve that problem by adding some fog, and fog is super useful. We'll add that to our material. There's multiple places where you can add it, but we'll get some linear fog. This is an attrui. It's ATTRUI that gives me access to the various attributes. So I'm going to make some linear fog and be able to control the density of the fog and the range of the fog. There we go. There's our fog coming into play. So let's try our fog. Yeah, there's our fog in the background from 1 to 2 meters are kind of fogged out. It doesn't look like much yet, but now watch when we change the fog color to match the background. You see they fade in from the fog. Because I've made the fog a dark gray, and I've also have a dark gray background. Or I could make the fog white and go here and with an attrui make the erase color of my world also be white. And now my fog is very effective, causing my objects to fade in. The one thing that's a little bit irritating about what's happening here, though, is a lot of blocks are sort of hitting me right in the face, right in the camera. I'd love to be able to sort of push them away from the center, sort of make a circle of empty space in the middle so that these things fly past me. And there are a bunch of ways to do that, but one way to do it is with our friends sine and cosine. Instead of having our x and our y here be simply mapped x to x and y to y. We've seen this formula before. I'll just use the x to create kind of a circle. Now see this, now I've got a path, I've got a sort of hole in the center. Why? Because I've arrayed, I've used my random x to, instead of be a linear random x, it's now a circular random x. So I'm arraying my objects around a circle. So I have a lot of complexity here. We've got a lot of stuff going on. One of the important things you want to do at a point like this is make sure you can close this and reopen it so it works again. We've made a lot of changes, and I'll show you a new trick you know certainly that you can, you've set the erase color here, and if you want to set it permanently, you can go at erase color and then put it in. It's white with 100% opacity, and turn this back on, and it comes back to life. But we put in a whole bunch of fog stuff, and that's a lot of work to type all that junk in. So what can we do? Is there any way we can just sort of get this all to dump right in there? There is. We haven't talked about this at all, but there's a little menu with an arrow right here. We click it, and we say transform changed attributes to arguments, and boom, it just drops all of that stuff in there. We already had our shininess, but it drops in our linear fog, our fog density number, our fog color, which is a little funky, 9934222, 99998. No, it's actually, our fog color is just 1. That's easier. Fog range, and then fog params is just a restatement of everything else. You can get rid of that. And now that's all in there. So let's see if there's any other values that we want to make sure that are saved. Like this scale here and the noise gradient. One thing you can do, by the way, we haven't talked about this, but the left outlet of a U menu will tell you the item number. So noise gradient is number 4. So that would be a load mess 4. It's going to get us right into noise gradient. We can load mess 1.6 here. We're not using this R time anymore, so we'll clean up a little bit. All right, so that looks like it's all gonna load up properly for us. Let's see what's happening in colors. We have noise distorted. Load mess 2. Load mess 1.2 here. So that's all going to come in for us. This is probably going to come in as offset 0, but yeah, why not load mess 0 just to be on the safe side? I no longer need that. I no longer need these fog controls because they're all put in as attributes. Let's see if there's anything in p pattern. Oh yeah, I like the pattern that's on these blocks. So I can, that's noise gradient, which is 4. Load mess 4. Load mess 1.4. And anytime you have something like 1.41, 1.4 is probably going to be good enough, and load mess 3.7 is probably going to look as good as 3.73. Not all the time, but usually you can simplify things a little bit, so you're just not dealing with as many crazy numbers that's left over from something else. That looks good. So we're just going through all of our various parts here and seeing if there's anything that we ought to be putting a load mess on. And then hopefully this is in a project now, and all of our files have attached, and all of our load messes are in. We should be able to close this, open it up, and start it.